Here are some examples for checkpoint 1. This video might be a little bit longer than usual, but you should pause it as you go through the questions so you can use this video at the same time you are taking your test. So there are 10 questions and I'm going to go over about 9 out of the 10 examples. So let's go for it. Number 1, it says match the angle with the classification based on this image. So you're going to go through these angles, and you can look at them as UVW. So this is angle UVW, and you're just going to trace, I keep doing that. You're just going to trace, I guess it wants to be on that screen. You're going to trace from U to V to W, and you're going to see this angle right here, and I can see that that is an acute angle. So you're going to go ahead and match the acute angle with the angle that you see in A. And you're going to do this with all of these angles. Now let's just go to this screen. So let's go to angle UVY. I go from U to V to Y, and we can see that that is a straight line, so it's a straight angle. Then we have WVY, and you're going to trace, start with W, go to V, and go to Y, and we can see that that is an obtuse angle. And then the last one is XVY, so we start at X and go to V and go to Y, and because of this box right here, we can say that that is a right angle. So again, angle classification, number 1. Number 2, Bo draws a regular nonagon and rotates it around the center. Which angle measures can Bo rotate the regular nonagon through to map it onto itself? So what you need to do is first find what is one rotation and then find the multiples of that rotation. So this arrow shows that I can rotate a nonagon from this spot to this spot. Just rotate the shape. Think of like you're putting in a puzzle piece. How many different spots can it fit into that puzzle? So we're going to rotate it to here. We have to calculate that. And remember from your unit test, you had to calculate this rotation. So the first step is to take your shape. We have a nonagon, so we have 9 sides. Your shape might not be a nonagon. It might have different amount of sides, but you're going to use this equation, m equals 360 divided by the number of sides you have, and that is your first rotation. So in a nonagon, we have 360 divided by 9. We can rotate it 40 degrees. Now this has drawn in, and you can do this also using Snip and Sketch or any other, or you can draw it on paper and just write down the multiples. 40 plus 40 is 80, plus 40 is 120, and you can go all the way around and say how many degrees can I rotate this shape until it maps all the way around to 360 degrees. Then you're going to find those multiples in this list. So we can see that 40 degrees is here. I don't see 30 degrees or 90 degrees anywhere in here. So 120 degrees is right here, and 200 degrees is right here. So 2 steps on number 2. First, find the first degrees of rotation right here, and then find the multiples by adding this to itself until you get 360 degrees. You could write them down as a list and then find them in the problem. The next one we are going to deal with coordinate rules. So you've got the coordinate rules a lot on this sheet, but you're going to use this for a reference. Again, let's just pick this one to reflect a figure across the x-axis. You're going to go from your mapping rule xy to x negative y. So this is just given to you as a reference for this next problem. So number 3, which graph represents a transformation of the red triangle using the rule xy goes to negative xy? So the one thing that you could do is take the red triangle and write down all of the coordinates, and then take the other color triangle and write down the coordinates and see if it is a negative xy. So let's just see, let's go back. Which one is negative xy? It's right here. So that is reflecting across the y-axis. So at least we know we're going to look for one that reflects across the y-axis, Where is that y-axis? It's right here. So it doesn't look like my red triangle is reflecting across the axis, so you can look through them. And the answer is letter C. Let me go back the lesson here. So if you see this y-axis right here, it does look like the red triangle is reflecting across that into this coordinate, but you can also, like I said, write down the coordinates and see if you get a negative x, y. So this one is going to be identifying the triangles, using the rules, and you can use this as a reference to see what rule was I given. Let's see if I can figure it out that way. So this one, again, reflecting across the y-axis. Here's my red triangle reflected to the blue triangle. Number 4, solve for x. This in this figure for blank 1, then solve for y in blank 2. Enter your answer without degrees. So you're just going to put the number in the blank so it doesn't mark it wrong. So just put in the number, no degrees. So again, we need to do two things for this. We need to first find this measure right here. And if you remember, solving for x, we use this equation, 180 times n minus 2. How many sides? 1, 2, 3, 4, 5. We've got 5 sides, 5 angles. So we're going to take the number of sides, n minus 2. So the interior angles, 180 times 5 minus 2. The total interior, if I add them all together, they should equal 540. And I'm just missing one of them. So all of these add up to 540 because of that equation. Then I can subtract all of these from 540 and solve for x. So x is 92 degrees. You could check your work by plugging 92 degrees in right here and see if they all add up to 540. The next step, so that's for blank 1, you have to find this. Just write in the number 92, no degree sign. And then measure of angle x plus y equal 180 degrees. So we have x plus y equals 180. We know that x is 92 plus y equals 180, and we're going to subtract 92 from each side, and we get the measure of y is 88 degrees. Again, just put in the number of your degrees without the degree symbol. Number 5, what is the measure of an exterior angle of a regular 13-sided polygon? Round to the nearest hundredth. If you need help, what is the hundredth? It's this one. If the one after it is a 5 or greater, you're going to round up. If it's a 4 or less, you leave it as it is. So you're just going to use this equation, 360 divided by the number of sides, and that is the 27.692. My answer would be 27.69. So again, you're going to take your number of sides, 360 divided by your number of sides, a simple formula for number 5. Number 6, the blue triangle is the image of the red triangle. The center of dilation is 0, 0. What is the scale factor used to create the dilation? Give your answer as a reduced fraction in the box. Use the / to type your fraction using no spaces. So this is the image. This is my pre-image. You can find the scale factor by counting sides. So remember, it's image divided by pre-image. So we have 7. We're just going to count. If anytime you have horizontal or vertical lines, you can count them. So the length of this line, and this is my image, is 7, divided by my pre-image is 14. Now, because it's flipped across the axis, it is negative. So if it's on top of itself or right next to it, it's a positive dilation. This one is a negative dilation. And you can see that by even looking at the coordinates. So this coordinate right here is 12, 0. This one is negative 6, 0. So it is a negative dilation. Number 7, based on the pattern of the drawings, which conjecture is reasonable to make? So let's look at the drawings. We have these two next to each other. They add up to 180 degrees. These two are next to each other. They also add up to 180 degrees. And these two are next to each other. These are all vertical or adjacent angles formed by intersecting lines. They are supplementary. Remember, supplementary means they add up to 180 degrees. Proofs, you've got resources here if you'd like to click on them, look at definitions from the classroom, and then postulates and theorems if you would like to read the definitions on those for some help. They are on this page. So I'm going to go through this number 8. This is a simple proof, but you need to go through and order the choices to fill in the blanks. We have this line segment given and this A to M to B. So it is given that point M is the midpoint of AB. So we have line segment AB and we have the midpoint. So line segment AM is congruent to, we have to write it the same way. So you're going to pick this one, line segment MB. Make sure you are choosing the right one by the definition of midpoint. Therefore, AM is equal to MB by the segment congruent postulate. And then so we have AM plus MB equals AB. So AM plus AM equals AB by substitution. So again, go through the proof. You are given your choices to fill in. Just go through them, see what fits, what you think, and then make sure you go back and read through it. Make sure it is grammatically correct, because sometimes finding out what goes in that spot can be found just by looking at the grammar. So this is the last one I'm going to go over. It is a proof, and we've got these highlighted spots we're going to fill in the blank. You've got your choices right here to fill in, and you're given your proof right here. So triangle ABC, we want to prove that measure of angle 1 plus measure of angle 2 plus measure of angle 3 equals 180 degrees. Again, in this first spot, you're going to put given. This is a given. So really, we only have these to deal with. So we have DBC and angle 5 form a linear pair. This is a definition of linear pair. Remember, the linear pair postulate after a linear pair of angles has been identified. So that's why this one is the definition before the postulate. So we have to define that they are a linear pair, then we can add them together with the linear pair postulate. So going from here to here, we have two angles added together equal D to B to C, D to B to C. We're adding angle 4 plus angle 3. And then we can substitute, saying measure of angle 4 plus 3 plus 5 is 180, and then again another substitution here. That is the end of this. Again, rewind, fast forward, pause, use this on your test. I hope it helps.